Students, we are asked to simplify 1 positive I raised to the power 18. Foremost, let me consider this to be a z. Let z be equal to 1 positive I. And we know that any complex number can be represented as, you can state that any complex number z is represented as r times cos theta positive I times sin theta. Okay, but my z is actually 1 positive I. So 1 positive I is equal to r times cos theta positive I times sin theta. R is the modulus, right? So that's going to be 1 squared positive, coefficient of I is also 1. So it's going to be 1 squared positive 1 squared, which is going to be equal to root of 1 positive 1, which is equal to root of 2. So you can state that r is equal to root of 2. You can place that in a box. Now you are expected to find alpha. Okay, now alpha is the argument. So alpha is equal to tan inverse of y over x. In this case, it's going to be tan inverse of 1 over 1, which is tan inverse of 1. Tan inverse of 1 is pi over 4. But clearly we know that, clearly we see that 1 positive I is in quadrant 1. Okay, so that means my principal value, principal argument theta will be equal to alpha. So that would mean theta is equal to pi over 4. Okay, so therefore the complex number z, which is r times cos theta positive I times sin theta, becomes 1 positive I times is equal to root of 2 times cos pi over 4 positive I times sin pi over 4. Okay, this is what we get. Now we need 1 positive I raised to the power 18, right? So raising it to the power of 18. So this means if I were to raise it to the power of 18, it's going to be 1 positive I raised to the power 18, root of 2 raised to the power 18, and you got cos pi over 4 positive I times sin pi over 4. This is raised to the power 18. Now we got root of 2 being raised to the power 18. So this is nothing but 2 raised to the power 1 over 2 is raised to the power 18, which is nothing but 2 power 9 by the law of exponents. Okay, so this is going to be 2 raised to the power 9 times, by de Moivre's theorem, this is going to be cos 18 pi divided by 4 positive I times sin 18 pi divided by 4. This is what we get. Now this is equal to 2 raised to the power 9 times, I can use 2 to reduce, so this is going to be 9 pi divided by 2 positive I times sin 9 pi divided by 2. This is what I get. Now I need to simplify this. Okay, so to simplify this, I am going to be rewriting the quantity 2 raised to the power 9 times cos 9 pi divided by 2 positive I times sin 9 pi divided by 2 as 2 raised to the power 9 times cos of, let me rewrite this as 4 pi positive pi over 2. 2 times 4 pi gives me 8 pi, added with pi will give me 9 pi divided by 2. Okay, so that is why it allows me to easily simplify the result. So positive I times sine of, similarly 4 pi positive pi over 2. So this is what I get. Now clearly this is going to be 2 raised to the power 9 times cos of 4 pi positive pi over 2. From trigonometry we know this is going to be cos pi over 2 positive I times sine pi over 2. This is what we got. Cos pi over 2 gets cancelled. So this is going to be 2 raised to the power 9 times I times sin pi over 2 is going to be 1. So this is going to be 2 raised to the power 9 times I. On the left side, we got one positive I, okay, and that is raised to the power 18, right? But 2 power 9 is going to be 512 multiplied with I, and that's the final answer. So 1 positive I raised to the power 18 would give me 512 times I. So that completes the solution to this question.